negative at all. I don't fly that. All right. Thank you all for coming. Where's my school? Huh?
Oh, she's walked the kids.
Yeah, but she has to go to the gate. All right. So thank you, Ms. Pineda, for offering your student work today. Really appreciate it. We're going to dive into the standard 7 RP3. Mr. T, you want to read the standard?
Use proportional relationships to solve multi-step ratio and percent problems. Examples: interest, tax, percent error. Know and show, exemplar.
You have to do that. So use proportional relationships to solve multi-step ratio and percent problems. For example, this one happens to be percent error. And so we want to take 1 or 2 minutes to quickly write a know and show. If you can do that on your own, that would be great. What do kids need to know and show according to this? I mean, we can even do it in real time. So take like, I don't know, 30 seconds to like think about it.
Do I get to see the example?
Not yet.
Okay.
We're just doing the standard right now. So what do the kids need to know in relation to this standard?
What the proportion is?
Okay, then you know what proportions are.
First, exactly percent error. I don't know how to word this, but how to identify the numbers in a problem and label them correctly, so like they can plug in. Does that make sense?
Yeah, you're talking about showing. So what you're saying is when to use proportions and ratios, or when to know how to use proportions, when to know when to use ratios, and when to know percents. Is that
Yeah,
what
or I'm just saying, like, for example, the percent error is actual minus exact divided by exact times 100.
So you're
They have to know, like, when to plug in the numbers. Like, that's the hardest part, is getting them to say, what's the exact, what's the actual, what's
Okay,
the approximate.
so the procedure for calculating percent error.
Sorry, I'm super congested.
Yes?
Isn't that conceptual too, though? Because if you're talking about like reading the word problem and knowing that the percent is a sales stat, I don't know the exact problem, but if it's a sales stat, you have to know like what the actual.
Yeah, the idea is conceptual, but this
no,
is a fluency.
percent is like per every 100.
Yeah. So what you're talking about is the show, I think. We'll get to that, when to know how to use it. What we're talking about right here is the
annotating the problem and saying what is going to go what.
the procedural, which is like more fluency, and then how to find out what they're asking for, right?
Is there a difference between calculating percent error? Or is it just the type of problem?
Defining like what, so this is the example.
Hold on.
No, I'm just giving him an example.
Okay, go ahead.
This jacket, I thought it was $30, but it was actually $35. What's my percent error?
So you're okay.
Finding out like how much I was off by.
Perfect.
Percentage wise.
All right, excellent. So now what we're going to do, I think as far as this standard is concerned, I think that this is a good know and show chart. What proportion of, I mean, I would even go a step further, the relationship between proportion and percent. And
Yeah.
percent error. Because what Mac just said is like, what's the difference between percent and percent error? And because we're talking about the use of absolute values here, and
Will they have to know absolute value?
Great. Oh, they have to know absolute value.
They have to know how to divide. They have to know how to multiply.
And then those are what am I trying to say?
Operations. I was like, what is it? Oh, operations.
All of that in order
Yes,
to be able
successful.
to get the right answer. Okay. Now, let's look at a teacher exemplar. Are you ready? This amazing teacher put together this teacher exemplar.
And I put this together in class. Well, I mean, okay, I take my notes in class with me.
So what I want us to do is take 2 minutes to write on this, and we're going to create a know and show chart for this exemplar, which happens to be lesson 8 from module 4. Is that correct? or module 7. No, module 4.
Right?
I
Like
think
the
that-
pages are out of order.
Yeah. And the exit ticket is at the end.
I'm labeling the pages because they got stapled a little bit out of order.
Oh, I'm sorry.
Or,
Did they?
yeah.
Oh, yes, they did. Take them apart. Go ahead and take them apart. My bad. That's my fault. You see? There he is. The cameo. The cameo. Okay, so let's review the exemplar. What are the keys to an idea? How does this align with the standard? And is there anything that you would cut or add to our chart? Think about those things as we analyze the teacher exemplar. Sorry. Highlight the correct answers, because I'm assuming we're going to compare these two students. All right, let's wrap up those thoughts and think about what the students need to know and show to be successful on this assignment. To be successful on this assignment. They might be the same, and they might be different, something that we can add or not.
Yeah, the lesson built, it starts with absolute error and then it goes into percent error. But the exit ticket is this right here on the second page.
Is this a part of it or something that's made up? Or?
I got some stuff online.
Sorry.
No, so let's do that. So what do the kids need to know to be successful on this assignment and show to be successful on this assignment?
I would still stand by the most important part is annotating and then labeling the numbers correctly as what they are and being able to plug them in.
Now, is this a formula? I know you talked about this before.
Mhm.
This is something, I've never seen this.
This is the
But
formula
this
I
is
saw.
they need to know this, right? They need to
Yeah,
know
and
the formula?
yeah, it's very wordy.
Exactly.
But yeah, so on the second, so I gave it to them fully, and then after I would start shortening it, like instead of writing approximate every time I wrote APP, and like percent I write PER. So yes, this is the exact.
So give me the formula.
Percent error equals approximate
APP.
minus exact divided by exact times 100. And you have to take the absolute value of the approximate, yeah.
Awesome. Kids really need to know this, or to be able to show that they understand the formula, right? So what do they need to know? I mean, we can just go back to here.
The operation.
They have to know operations.
Absolute value.
Is it important for them to know the relationship between proportion, percent, and percent error? What do they need to know?
I think for this it's not very important.
Okay. So which one of these would you say that they need to know really well? Like have a good understanding. Portion, percent, or percent error?
Percent error.
I think they just need to know the kind of relationship between the formula and kind of common language, because it looks really fancy and if you're looking
And And that's what I tell them.
Communicated to
And
them.
that's exactly what I say in my lesson. This is gonna sound so scary and overwhelming. This is a lot of words, but literally, this is what I told them. You're just gonna take the problem and you're gonna circle numbers and then you're gonna plug them in where the words are. And you have the same word repeated twice, so you're gonna have the same number repeated twice. And I try and always tell them that it seems wordy, but once we find it and you plug it in, it's gonna be like so simple. And they did actually catch on after multiple tries.
So that kind of goes under annotating and labeling. I
Yeah.
would say like really knowing, I would even add it, knowing which one is the appropriate or the approximate and which one is the exact.
Yes, knowing the difference between them, that is super important.
And part of annotating, kind of rewording it in your own comfortable word, language is comfortable to you.
Mm-hmm.
Yeah.
You can comfortably-
So yeah, a lot of the problems would say, I thought that this jacket was 35, but it was really 30. So then I would say the approximate is what they think. It's like their guess, their estimate. And then exact is that, because then they would say, but the actual cost is 30. So then I would say exact is actual. It's how much it really is.
So what else do they need to know then? You're talking about, I think, academic language.
Mm-hmm.
That's good. Okay. So, I think it's a great list. Is there a gap between? Is there anything that you would think like, does this kind of allow the kids to show what we decided?
They should know how to shortcut that multiplication of 100 you shift in the decimal. Right?
Yes, that is correct. But the only thing is like, I'm trying to think of when I run into issues with that. It's when it's like repeating, or like, I do say it right here. So on it tells me to multiply by 100, but then I would tell them to move it over twice. I told them a trick. I'm like, if you're going from a percent to a decimal, you move the percentage sign, take one of the dots and move it over twice, and then make it a decimal and take the percentage sign off. If you're going from decimal to percent, you move a decimal over twice and use that dot to turn it into a percentage sign. And that works really well, but I can't think specifically, but there was some time when it didn't work well. I think it was like, if it was like 0.2, they would move it over twice, and then some of the people forgot that in the extra loop you have to put a 0. So that's why I just started saying multiply by 100, because then you can get the correct answer and it doesn't throw them off as much. But I remember there was a reason why I had to start saying multiply 100, because some people were forgetting like, oh, in this little loop there's supposed to be a 0.
And go ahead.
No, mine's not really important, but it's called the baby butt. And I'm just saying that because my old teacher, I used to watch at my old school, when you move the decimal over twice, if you do it on the board, you'll see it. It looks like a little baby butt.
Oh, the little loopy thing? Yeah.
So you should use that as he would always say that, and kids will remember when moving it over. I think one of the ways it's like a little baby butt. And that's how they remember it. So,
I'm going to direct your attention to a gap that I saw, and I want us to have a very short discussion about it. If you go to exercise number 1 in the exemplar, when I was reviewing these, I was confused about which one was exact and which one was the approximate. And so I wanted to have a quick discussion about it, and I know that if I was confused, I know the kids are going to be confused. So it says, and I'm going to just annotate really quick, Mrs. Moore's students were directed to weigh, so that she said, right, go weigh a 300 gram mass. Vanessa, you listed this as the exact. Tina weighed the object and reported 328. And then you listed that as approximate.
Yeah, a lot of my kids got that confused at first. So the reason why I tried helping them understand why 1 is approximate is because we had watched a video previously that day to start off the lesson, and it was talking about how there could be human error. For example, if the scale is off, or like one of the problems, it says like someone was goofing around, so then they got the wrong measurement. So that's what I was trying to tell them, that like it's telling you that they're going to weigh something that is 300 grams. But when this student weighed it, that's what she reported, and her report isn't the exact, hers is the approximate because it was off, and so,
Off of the 300 goal.
yes.
You see how this is really confusing, right?
Wait,
And you
was
just said,
this the Engage New York answer?
Mhm.
See, I would disagree.
tell us about why you would disagree.
I have, this happens all the time in Engage New York, but like,
Yeah.
this is a
Yeah.
perfect example of like what I used to do for my bachelor's, right? Like the idea is that you are going to the scale to weigh a 300-gram mass. You're never going to, like what you were saying, you're never going to get exactly 300 because of human error.
Mm.
But like, it's almost like what actually was reported is the actual.
Yeah, because that's how much it did weigh for her, is what you're saying,
Yeah.
yeah. But what I got out of it is like, it's saying that she made an error, that's why it's not.
Because like also from a scientist perspective, she's 28 grams over. So like even though it's an absolute value, before you apply the absolute value, it's a negative to tell you that it's over. Under would be a positive number, but it depends on what kind of scientist you are. Do you see what I'm saying? The equation is approximate subtract the exact.
Right.
So
Well, it makes a
Well, that's
difference.
not- yeah.
It makes a difference because of the exact being at
You have to divide by it.
the bottom.
Mhm.
And so
yeah, that's
your
really what it
calculation
makes
is
a
going to be a little bit
You're right.
off,
You're
depending on whether we want to do this or not. But because of the wording is so kind of like obscure, and then the other ones are pretty straightforward.
Yes,
Exactly.
Right,
Mhm.
right,
that.
right.
And then so let's look at the student work. What I want to do is look at the student work and see what the students did. So I think I just have a few of these, but.
Right, so Johnny, you're just pointing out that it's not crystal clear.
Exactly.
But
Yeah,
that's
no,
not
but
right or
Like if
wrong.
you're using your students as a
Unfortunately,
data
that is
people,
engaged,
yeah.
like,
No,
I don't always agree with
But
that
at the same time,
Well,
we're going into a level of like, we're talking about bachelor's and
Tomato,
sciences.
tomato.
No, what I'm saying, it says right here, engaging for kids in it. And
Yeah,
for
yeah.
seventh grade, it says, we're directed to weigh a 300-gram mass.
Mhm.
It says a 300-gram mass.
Mhm.
So it weighed 300. That's how much it weighed. That is the exact amount. It's very clear in there because it says it weighed
Okay.
that amount.
Let's see what the kids did.
Well, you can always change the
Absolutely.
you know,
Absolutely.
easy.
Well, or do you have to change the word?
Well,
There's nothing wrong with the kids like
No, the kids-
struggling
it
with
goes
this.
to the biggest challenge, which is getting the kids to kind of immerse themselves in a real world problem.
Yeah, no, I was just thinking like,
Yeah, exactly.
I'll just take one.
And I'm curious to ask the question is how many kids came up and said, Ms. Pineda, I don't get this part. It says this, but it's
Yeah,
saying that.
Like this person did Engage New York way.
okay, well, no, we went over the problem as a class.
Oh, so if they made a
Some
mistake, they would
students
correct
started,
it.
because I made them do one on their own, and then I said, move on if you're done. So some started it, and then the people that did start it, there was a handful that were saying, oh, I don't get it. So then,
Okay.
when we went over it as a class, I had it,
It looks kind of like this person below had it the other way around.
yeah.
You know what I mean?
Mhm.
Like
A lot of
initially-
people did, yeah. And then we had to do it as a class. But yeah, that was the most challenging one.
No, like if this problem was in a science lab in college, the exact would be the amount you weighed.
I would be confused by it if I were a chem, in my chem,
I'm just saying,
103.
it's, yeah,
Well,
like
with
an
the
adult.
but with the balance scale, those are.
Because
The
when it's-
exact is what was
Well,
weighed.
no, a balance scale could be thrown off if it's not level perfect.
that's
But
what
it
they're
doesn't,
saying.
There's a lot-
no,
but
no,
how
it's
are they
not,
supposed to
it's
know
not
that?
what number
Right.
was reported. Do you see what I'm saying? It's not what number was reported, it's what does the scale read? That is your
Well, I'm
exact
saying,
measurement.
I think this is a way
Approximate
the
is
scale
like-
reading wrong because this
Yeah,
300 gram
they're trying to
mass
say
is
there was
a
an
way to
error.
say whether the scale is right. It's a calibration.
my point, and this is great discussion, my point to this is that both of you are absolutely right.
Right.
But
I hear what you're saying.
you see
But
what
from
I'm
a
saying?
scientific perspective,
I know,
percentage
that's what I'm saying,
error
that
is,
you're both right.
it's like lab error, but it's due to the, it's not
So-
due to the scale being wrong,
No,
it's
yeah.
due to like a human can't pull out
Right.
each grain and be like, each grain weighs
Right.
0.03 of a gram.
And that's what I think is important here, is that both are correct, because when I was doing this exemplar, it stopped me dead in my tracks, I was like, is this right? And then I went and did it again, and I was like, I think both of those could be the exact. Yes.
Yeah, cause,
Ms. Palmer.
I'm sorry.
The to use one.
Andrade, in lab, you call it actual and measured. Do you know what I mean? Like,
So, let's identify a gap then between the student work, or in this case, I think we can identify a gap between the student work and the exemplar. And I want to kind of focus on this. What do you think the gap is here? Between what the kids are asked to do and what we think the kids should be able to show.
Annotating and labeling correctly. No, because I said we went over it as a class, so if they did get it wrong, they probably fixed it.
What did you say the gap was?
Between annotating and labeling it correctly.
Yeah, I would say
That's
that.
and you know what? Like, what I realized is, like, you know how we do our overviews, and you guys ask us to write down what the gap is. You really can guess, but the only way you know the gap is from experience.
Mhm.
Like, if I did an overview after my lessons, it would be so much more thorough because I would know exactly what happens, and it's just, yeah, you
Yeah.
can experience it.
Or if
so
you're doing like the
much
same module, you might be able to guess one day ahead.
Yeah.
Very rarely. I
But
understand.
yeah, for me, my like lessons
If you're doing
change every
something
day.
very too,
Yeah,
like,
yeah.
And they should. I think they're supposed to. I think planning ahead is great, but you're absolutely right. To get a great, and that's why we're doing this now, because it's glaring to see. I mean, it was for me anyway, to see. And I went through all the student examples, and I think all of them performed according to this example. But the point to my, in this case, the gap is that this is going to be really confusing for students.
Mhm.
So because that gap exists, what do we have to do now in moving forward with engaging? You guys do this already, I know. Is not eliminate that question because it's unfair. Rather, I think you just said it, Vanessa. Teach the kids how to annotate and find out what and label so that you can know when to use and how to use percent error. I think that's the gap.
I was gonna say, but the words, you and Palmer, we got a room full of scholars and we're going back and forth about it. So like words are up for interpretation, so I think it's very difficult. I'm not saying, I don't know how to say, but I'm saying, we just had a discussion about it. And we're still like, well, Palmer thinks one way, you think another
And
way.
there's nothing wrong
So
with
it's
kids
like-
having a discussion
So
about
it's
it.
kind of like, but I'm just thinking like,
What do I let them say? Like, okay, yeah.
if you're gonna do it by yourself and interpret it, I mean, it should be like a clear answer with math. Well, I don't know how to say.
Yeah, it's not like ELA where it's
How
like
many
gray.
problems are we talking about out of how many problems? We're
What?
talking about one out of how many?
Well, no, engaged New York has a lot of
Yeah.
times where, well, not exactly the same thing, but where annotation, the kids just don't.
Any curriculum would.
Yeah, you're right, because word problems are something that, like we said, we need to annotate,
Right.
we need to teach that.
Yeah,
as a
well,
better
that's
So
what.
as far as like
skill.
a
Understand
gap and what we
and
do
then
now for,
language.
to kind of like address this,
Yeah.
and to make sure that the kids are like supported, great, in finding out, or like in this case, labeling, annotating which one is the exact and which one is the approximate. What can we do for them to make sure that this discussion happens,
Break
but
down
that we
word-
like move towards consensus for each problem?
Break down word problems, annotate with them, teach them how to annotate, bring in like,
So.
I mean, those are all things I do, and like that's what when I started word problems, I actually spoke to Mr. Matt, and since it's my first year teaching, I didn't realize like my thing was like, oh my gosh, they need to memorize this equation, and he taught me the equation is going to be so easy, which is true. When I label it, they're like boom, 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 they're like going, they get it. But for them to read the word problem and understand it and label it correctly, that's the toughest part. And he said that's what is the toughest job of a teacher, is getting them to label that problem on their own and getting them to separate it.
So let's write this down, Vanessa. You ready?
Yeah, you have something to say.
Yeah. Well, hold on, just a second. If I had to pick one, if you had to pick one or the other, modeling or guided discourse for a problem like this moving forward, which one do you think it would be? Modeling, most of the kids did not understand anything. Guided discourse, the kids understood it, but they need help with a certain aspect of the problem.
Are they gonna help me?
Which one is it?
You want to,
Tell me.
You're asking Vanessa, right?
Well, I'm asking all of them.
For me, it's a sequence. You start off with the model, then you transition into guided discourse, and you transition into partner practice, and you transition into independent practice.
That's guided discourse, that's not modeling. Modeling is a whole lesson geared towards just
Oh,
explicit things you want to see, and everybody has to be on the same page.
Modeling.
Guided discourse, so write this down. For your reteach for this, I'm going to recommend a guided discourse.
which entails the first part of the
Mhm.
process being modeled
Absolutely.
with narration, followed by metacognitive questioning, combined with modeling, followed by, yeah.
And how many examples would you use for this?
It depends on
20, 30,
it completely
3
depends
to
on the
4.
process. No, I mean, when you're talking about 20, 30, that's the fluency, that's at the end, that's the independent practice stuff.